All right, so in this video I'm going to show you how to use a DC motor controller. And the reason we need to use a motor controller to control this DC motor that you see right here is that we probably want to be able to control the direction of the motor. Well, there's two problems. The first problem is that this motor takes more current than our microcontroller can supply. The pins on our microcontroller can only supply about 10 milliamps of current safely. And this motor is going to use somewhere in the neighborhood of probably, I don't know, up to 500 milliamps, half an amp. So we need to have some way, with our servo motors, we were just sending it a pulse. We actually connected the 5-volt supply and the ground directly to the USB input. Now, this motor's going to draw too much for even our USB input, so we're going to have to use an external power supply. So I'll show you that here in a second. But with our servo motor, we were just sending the pulse wave modulated signal between 0.5 milliseconds and 2.5 milliseconds to tell it what position to move to. So we weren't actually giving it the current via that pin to have it move. It was getting the current direct from the USB connection, and then we were just controlling it with that pin. But if we have a DC motor that's just got two wires, it's got ground and it's got positive or VCC, we wouldn't be able to, we would have to connect one of those to the 3.3 volt output pin. So let's say we connect ground to ground. That's typically what you would do. We would only be able to give it 3.3 volts through the output pin. We would only be able to give it 10 milliamps, and it would not, we would either fry our pin by trying to give it too much current, and the motor wouldn't spin very fast. So we need to have a way to switch power to the motor with that output pin on our Pico. So that's what this guy right here is going to do for us. So this right here is a motor. It's called an H-bridge. An H-bridge is going to allow you to do bi-directional control of a DC motor. So this does a couple of things for us. So the first thing you can see is that I've got the connections here on motor A. So you can see right there where those wires are going in, it says motor A. And then you can see over here, I've got it connected to A1B, so that orange wire is A1B, and then A1A, and then VCC and ground. And all of those are going to, on my microcontroller, pin 3 and 4, and then ground. Ground is ground. We connect all of our grounds together. And then I have this battery pack over here that is, I have connected to the positive on this rail and the negative on this rail. So I've got my negatives tied into my negative on my Pi Pico, so that third pin on this other side is ground. So I've got ground going to ground, and then I've got, let me see if I can show you here. I've got those wires from this battery pack going in and connected to the positive and the negative on this rail. And that is what is connected right here. So if I was to remove, I'll just show you, if I was to remove a battery from there, this light turns off. And if I pop this battery back in, then we've got power again. So you can see that the power is actually coming from the battery pack to this. Now, the control signal is pin 3 and 4 on my Pi Pico. So that is going to not be giving it the power, but going to be just like we did with our servo motor, telling it how to move. And all we do is we basically give it a high signal on pin 3, and it makes it move one direction. And we give it a high signal on pin 4, and it makes it move the other direction. So with that said, let me show you this code. So I have a while true loop, And all I'm doing is I'm telling it to move forward, turn on the green LED. So green is going to indicate it's moving forward, and you can see the green LED is on currently right there because I had been running the program and I stopped it. So green is forward. It's going to sleep for 2 seconds. It is going to, sorry. Sorry, my camera went to sleep. So it's going to sleep for 2 seconds. Then the motor's going to run it. I'm going to run it at 30% speed. So this is another thing with this motor controller we can do. We can give it a pulse wave modulated signal to tell it how fast to allow current to flow to the motor. And in the same way our servo motor, we were able to, or our LED used pulse wave modulation to reduce the current flow and have it not be as bright, we can slow down the speed of our motor, our DC motor. Have it sleep for 2 seconds, and then I have it turn off the green LED, and then it jumps to make it run backwards. And I just use the red LED to indicate that it is running in reverse, going backwards. Have it do the exact same thing. Full speed backwards, sleep 2 seconds, slow speed backwards, and then go back to forward. So let me show you that this works. So you can see that the motor there is was running clockwise, and it's slow. So clockwise, 2 seconds, slow 2 seconds. Light turns backwards, counterclockwise 2 seconds, slow 2 seconds. And you can see the LED toggling. So we're doing exactly what our code said. This gives us the ability with a microcontroller to control a DC motor that's going to be drawing more current than our microcontroller can supply. The DC or stepper motor driver that we're using, it's actually a stepper motor driver, but you can also use it to control 2 DC motors. So you could have 2 of these yellow motors connected, one to motor A and one to motor B, or you can use a stepper motor, which I think we talked about in class already. It has 4 wires, and you have to connect all 4 of those wires up, and you can control one stepper motor with this driver. So this gives you the ability to now have motors that you can control, DC motors, cheap DC motors that you can control. You can control their speed. Just note that whenever you give them less current to slow them down, they don't have as much torque because they are not able to draw as much current to turn with as much torque. So whenever you reduce their speed this way, you're also reducing their torque. And that's just something to consider. All right, hopefully this was helpful.